Hi, this is Maggie. In this video we're going to talk about developing a multi-level game. This game is a very simple one-level game called topdown.py. It is composed of a background sprite that constructs itself from a terrain map, a player, character, gold coins, and a scorekeeper. The terrain map includes bricks that the character may not move through, and the location of the coins, and the character can collide with the coins to add them to its coin collection. The scorekeeper displays the current level and the number of coins the character has collected. The tiles are from a tile set in the SpriteLib GPL created by Ari Feldman, and the coin animation is from opengameart.org and was created by the user Don'tMind8. Now, although the scorekeeper displays the current level, that's simply a stub or a temporary placeholder. There really aren't any levels for this simple game. Let's think about what a new level might entail. Generally, as a player moves through levels in a game, the levels get a little harder. The terrain also usually changes or, again, gets harder to navigate. The player might gain abilities or lives. I'm going to keep this game very simple, but leave it open for you to make changes. For example, you could add tiles that represent hazards, such as pits or fire, that the player character must navigate around. You could add enemy sprites that try to navigate toward the player character. You could have goals besides the coins. The coins could disappear after a certain amount of time. And I think you'd certainly want background music, and you'd want the music to change with each level. But for this simple example, what I'd like to consider a new level is a game with a different terrain map, and I will also enhance the coins to disappear after a certain amount of time has passed. That amount of time will reduce as the levels get higher, so the player will have to choose the best path to maximize the coins they pick up before they're gone. Ideally, when we write a multi-level game, most of our code is reusable. You don't want to write a whole new game with a lot of duplicate code for each level. So we must figure out, for the kind of levels that we want to have, how best to reuse most of our code while implementing levels that feel different to the player. There isn't one universal solution to this, but you should be able to implement a level class that can have data and responsibilities and that the rest of the game can interact with. So what we will do is encapsulate that level information in a level object. We already wrote a stub, which is a level class. A level class, which is a definition of an object, is like a sprite class, which is a definition of a sprite. It's a data type that we write ourselves, which usually includes data that can be a collection of related elements of different types and operations on that data. So for a level, if I'm going to have different terrain, the level could keep track of the terrain map and the tiles. If there were music, the level could keep track of the music file. And if the coins behave differently, the level could create the coins, or it could hold the information that had passed to the coin's initializers. So when we define the level class, the level holds all of the information that is unique to a level, and it can perform any operations we need a level to perform, like generating enemies, for example. And then when we create specific level objects, we give each level object the unique information that it needs for the level that it is. So the level 1 object has the level 1 terrain map information, level 1 coin information, level 1 music. The level 2 object has the level 2 terrain map information, level 2 coin information, level 2 music, etc. So what I'm going to do is enhance the game so that the coins disappear after a particular time interval. And the only reason I'm adding this feature is so that our levels are both a terrain map and coin behavior, just to make the program a little more interesting. So I'm going to pause the video, do that, and return. Okay, so quickly, here's what I did. I added a parameter to the initializer of the gold sprite called disappear time. And I have two new fields, disappear timer and disappear time. And I renamed the original timer to rotation timer because that's used in the coin animation. In update, I take the group that contains the coins as a parameter. Before we rotate, I've added this code to increment the disappear timer. And when it reaches disappear time, I remove the coin from the group. If it's not time to disappear, we rotate the coin. Once the coin is removed from the group, it won't receive the update message again. In the background object, which is where the coins are created, I've put a time in of 30, which means the coins are going to disappear after a second. I did that so we could see the coins disappear without running the program for very long, although I'm sure we'd want to give the player more time to grab them in level 1. Let's run that so you can see the enhancement. Okay, so we now have two things that are part of a level: the amount of time that coins stay available for collecting and the terrain. Right now, here's the level class, and it's a stub. Let's make it more interesting. We'll add some fields. One for the number of the level, which is an integer. And then a level is terrain and the amount of time the coins hang around. I think I'd like the level to be in charge of creating the background and holding on to the lists of bricks and gold. So I'm going to add fields for the backgrounds, the bricks, and the gold. In the initializer, we'll pass all of the values in that the level will need to create the background, bricks, and gold, what level it is, and the amount of time that the coins stick around for this level. So just as with sprites, we define an init method with self as the first parameter. And we'll call super.init. Although we don't have a superclass to initialize like we do with sprites. And I'm putting it here because I think it's a good habit. Okay, so we'll pass in the terrain map and the tiles list, as well as lists of what numbers in the terrain map should map to gold, and what numbers in the terrain map should map to bricks. And we'll put in the length of time the coins stay visible. All of that will get passed along to the background, which means we'll need to add the coins parameter to the background initializer and pass it into the gold initializer. Let's do that now before we forget. After calling super init, we create the background and get the bricks and gold from it and set the level. And then we'll have accessors for all of the fields. I want the game to interact with the level and not the background. So I want the background to be basically a part of the level. In the accessor for the background, I'm going to return the background image. This will simply be blitted to the screen. Since it doesn't scroll, there's no need to be putting it in a group and updating it. So let's modify main to work with this and create just level 1 and make sure we have this working the same as before. Then we'll modify the level and pass in some values for level 2 and play on level 2 to verify that we can easily change the level simply by creating a new level object and connecting it to the main function. Okay, so instead of initializing the level 1 stub, I'm going to pass in 1 for the level number, 120 for the amount of time for the coins to hang around, image files, which is the terrain files, castle.text, which is the terrain map, and then the list of 0, which is the barriers list, and the list of 2, which is the coins list. Then I'll get the background from the level, and I need to change things around so that's a surface and not a sprite. Which also means updating the clear update draw area. And I'll get the bricks and the gold from the level. I shouldn't have to change anything else. Let's see how that works. Okay, it works the same. And if we wait, the coins disappear. We might want them to last a little longer than that for level 1, but we can play with that to figure out what works best. let's make changes now to create level 2 and play with level 2. I've already written a new terrain file, and I've grabbed a couple of different background tiles from Ari Feldman's free tile set just to make the level look different. I didn't make the coins look different, although that would probably be a good idea too. I basically just named everything with 2 after them, so barrier 2, etc. So I can quickly make level 2, and then we just need to get the background bricks and gold from level 2 instead of getting them from level 1. Okay, and it looks like a new location. The only issue is that I want the player character to appear in this level where he left the last level, which is down here on the left, which makes leaving more difficult. Also, the way that I've drawn the scoreboard at the top means I can't see the top barrier, which also obscures the top exit that I've put in. And of course I'm only using 2 tiles, and they're really not meant to be put together this way, so it looks kind of ugly. But making it look good would use the same principle, just a little more work. That's stuff that can easily be fixed, but that I probably won't bother to fix for these videos. I'll leave that to you. So that is how to create a level class and level objects, and again, it's a general principle and not a single fix. Depending on how your game works, you might want to assign your level different responsibilities and different data. Your guiding principle should be to reuse as much of your game code as possible while giving the level a coherent set of responsibilities. You might take the top-down.py program and try to recreate this version with levels for practice. You might have a different idea of how this should be done. Once you can do that, you're ready to move on.